Good morning or afternoon or whatever time you're looking at this. We are starting a new chapter. Chapter 10 is all about correlation and regression. You have done linear correlation problems before in algebra. So let's just talk about what a correlation is. A correlation will exist between two variables when the values of one variable are somehow associated with the values of the other variable. Now, if you look, I've drawn a little diagram here of a scatter plot. And this appears to be a positive correlation. And its R value, or its linear correlation coefficient, as we see that's what it is down here, is about 0.851. The closer it is to 1, the more of a correlation there is, the stronger that correlation is. Here's a negative correlation, and if you'll notice, I've got these points a little bit tighter. So you can see this is negative. I'm sorry, I didn't want to start over, but this is negative. Left my white out at school. 0.965, which is closer to -1. So this one has a stronger correlation in a negative direction. And if you look at this one's all over the place. R is equal to 0. There isn't any correlation with those points whatsoever. So the linear correlation coefficient is R, little r. The closer the absolute value of R is to 1, so if we took this absolute value, we would get 0.965. The closer the absolute value is to 1, the greater the correlation, or the stronger the correlation. Now we're going to be doing hypothesis testing for linear correlation, and we're going to be using a test statistic R. The notation that we have for this information is N is the number of pairs of sample menus? The number of sample menus, okay, data points. R is equal to linear correlation, the coefficient for a sample. Remember, the small letters that we use for the regular alphabet go with a sample. This is rho. You've seen this before in physics as density. Rho is a linear correlation coefficient for a population of paired data. So the Greek goes with the population, as we've seen before in the past. In order to do a hypothesis test, the requirements we need to meet: the sample must come from a random, simple sample of quantitative data. So it has to be a random sample. The scatter plot should show that the points are close to a straight line. There are no outliers, so we aren't going to be using any outliers. The notation for the hypothesis test. The null hypothesis is that rho is equal to 0, which signifies there is no linear correlation. The alternate will be rho does not equal 0. We're not going to be using less than or greater than in this. We're just going to be using equal and not equal. So that's pretty simple to relate to. There is a linear correlation. If we reject the null hypothesis, there is a linear correlation. If we fail to reject the null hypothesis, there is not a linear correlation. Don't look at that. There we go. Now we're going to be using the test statistic R, which I will send to you in a form. I will give you the table A6. Table A6 is a small list of values for R. I'm just going to pop this up on the screen for you so you can see it right off. This is the table that we will be using. It only has alpha is equal to 0.05 and alpha is equal to 0.01. And you use the N, no degrees of freedom, just N. If you have 6 pairs of data, you use 6. So this is the table. I will be sending you a copy of that. I don't know, you may already have it with the other tables that I gave you, but I might not have made a copy for that. Okay. When you draw your conclusion, if the R value is greater, the absolute value of R is greater than the critical value that you saw in the textbook, reject the null hypothesis, include there is sufficient evidence to support the claim of a linear correlation. If it's smaller than the critical value, we fail to reject the null hypothesis, include that there is not sufficient evidence to support the claim of a linear correlation. Now your calculator steps what you're going to do is you're going to have a set of data that you're given, X and Y values. You'll plug the X values into L1, plug the Y values into L2. If you do it the other way, if you plug the values for X into L2 and Y into L1, you are going to get the same linear correlation, regardless of which you designate the X or Y values. You're going to press Stat and select Test, and the test that we will be using for this is a lin-reg-t test. And what will pop up, which I'll show you later, will be a p-value and there will be an r value. So without further ado, let's get to a problem. Okay, an example problem. And I'm going to take a picture of this and show it to you. You will actually have the homework paper before you look at the notes. So I'm going to actually do number 13. And I'm going to read it here. You may already have a copy of it at this point in time. Let me get a blank sheet of paper. And I'm actually going to do number 13 on page, for those of you who took a book, 532. And I'm going to do an example problem for you that's number 13. Now, I'm not going to copy down the data points. I already have them in my calculator. So they are saying that the consumer price index, which is a CPI, and the cost of a slice of pizza, they want to know if there's a linear correlation between the CPI and the cost of a slice of pizza. Now, if you notice, there's a little table there, and the CPI, I'm going to plug that into L1, and the cost of pizza, I'm going to plug into L2. Now, the directions in the beginning told me to use alpha is equal to 0.05, and they also show me that there are 6 data points. So that means there are 6 paired values. What I'm going to do first is I'm going to look up my critical value. Because I know alpha is 0.05, I don't have to split it in 2. Okay, just leave it as 0.05, whatever it is, you use what the alpha is. This is 6, my critical value. I'm going to go back to my critical value chart and put this in front of you so you can see it too. N is 6. Alpha is 0.05, so it's 0.811. My critical value is 0.811, and I just lost my paper. So get a nice look at my table. 0.811. Now they assign that a positive value. We're going to be looking at absolute values in the end anyways. Some books will say that to make this plus or minus, depending on what type of correlation you're looking at. You could have a negative correlation, you could have a positive correlation. So now what I'm going to do is I'm going to get my graphing calculator out. Let's see if you can see this, my lights are reflecting on it. So I'm going to clear that out and quit. I'm going to go to Stat and Edit, and you'll notice I have under L1, I have put the CPI. Under L2, I put the price or the cost of a slice of pizza. So they are in there. So the next what I'm going to do is I'm going to go to Stat, then I'm going over to Tests, and I am going to scroll up to get to it. Lin-reg-t test. F, lin-reg-t test. I'm going to hit Enter. And I have my X values in L1, my Y values in L2, frequency leave it at 1, and you'll notice that I have a little row there. I think it looks like a row, it's got a tail. Not equal to is what I'm going to use. I'm going to scroll down till I get to calculate, hit Enter. And you can see that my p-value, I'm having a hard time seeing it through here, 3.260 I'm just going to move that away for a second. Times 10 to the negative fourth, which is much smaller. Oops, my cord's in the way, my calculator's charging. Than 0.05. Oh, I forgot to write my null hypothesis. My null hypothesis is that rho equals 0, and my alternate is that rho does not equal 0. This means no linear correlation. And this means there is a linear correlation. I'm just checking to see. I'm not going to start because I'm just checking to see if there is a correlation. All right, so now when I look at my calculator, I don't see R. So I have to scroll down to get to it, and there it is, 0.985, and that's extremely close to 1. So this will have a linear correlation, 0.985. That's my test statistic. And I want to show that that's greater than my critical value. So now we come up with our conclusion. We reject the null hypothesis. There is sufficient evidence to show a linear correlation between the CPI and the cost of pizza. You can put a slice of pizza. So basically what they're saying is, with the economy the way that it is, that those two values seem to increase at the same rate. Now let's take a look at the information. Well, I was going to do a static plot of this. I have something else in there, so bear with me. Oh, I'm graphing something from before. Yep, I want to get rid of these things. Okay, now I want to go to a stat plot, and I want to turn it on. And I want to go all the way over to the line. And now I go to zoom 9, and I should be, oops. I didn't turn it on. If I go to zoom 9, I should be able to see a nice linear pattern of those points. Now, if it was closer together and it was scaled correctly, it would look more linear. But it would be a linear pattern if it was scaled better. Okay. If you have any questions, let's just go back over this real quickly again. So what you're going to do is you're going to have an ordered set of pairs. You're going to put one of the values in L1, the other in L2. You're going to look at the significance level. I would put the null hypothesis up here further. I mean, I would, but it went out of order. I would just put that up here a little bit earlier. Does it matter? Not really. I have everything I need. I have 6 sets of data points, and I went and looked. This came from the table. With n is equal to 6 and using alpha is equal to 0.05, that's what that was. My p-value, don't forget that if you see this here, that you probably have a negative exponent, which is much smaller than 0.05, which tells me that this is low, the null must go. So this gets crossed off. There is a linear correlation, and when we went to the calculator, we found the test statistic to be 0.985, which is extremely close to 1, greater than 0.81, so we are going to reject the null hypothesis. There is sufficient evidence to show linear correlation between the consumer price index and the cost of a slice of pizza. I hope you understood. If you need to, watch it again. Hopefully you're all watching this. If you are watching it, do me a favor, and when you hand in your work, put a smiley face at the top, just to show you actually watched the video. Take care. Have a great weekend. Miss you guys. Bye.